Hi everyone, welcome to this video. Today we are going to see a new type of analysis that is called repeated measures ANOVA. It is especially appropriate to see the effect of a repeated measures factor over an interval level variable. So here we have a very simple repeated measures factor that is basically the month, because we have measured statistical levels at different time periods. So you see that it's a repeated measures design because the same case here, for example, case 1 has been measured 4 times. So it's different from a group factor because individuals have not been measured either in September or in October or in November or in December. They actually have been measured at each time point. So what we want to know is if there is a variability within individuals. Right? So in other terms, we want to, when we expect to see an increase, just like for this participant here, in statistical level, maybe because of a wonderful course, right? So how do we check that? So we check that using a repeated measures ANOVA, I just said it. So analyze general linear model, and we want to do a repeated measures ANOVA. Alright, the first thing that is going to show up is SPSS is going to tell us that is great, but I don't know where to find the different information. So of course here it could have guessed because there are only 4 columns, but SPSS does not know how to order them. Right? You have to tell that this is the first month, this is the second, this is the third, and this is the fourth. And also you may have a bunch of variables that SPSS does not know about. Here it's not the case because it's a very simplistic data set. So the within subject factor name is really up to us how we want to call it, but of course here we have different months, so let's not be original there. Let's say that it's called month. And how many levels we have? We have 4 repeated measures. The number of levels is actually the number of repeated measures that we have. Let's write 4 here and let's click add. So here it says we have 1 within subject factor, that is the month, with 4 levels. Turns out we could actually add more than that, but here we are focusing really on that simple example. And that's it. Let's click on define. So here, SPSS knows that there are 4 levels for the month variable. 1, 2, 3, 4. Doesn't know where they are. So we need to tell SPSS that the first month is in this column. Right? So here, I'm selecting this one. I can either drag and drop it here, and I can also select it and click on this little arrow over here. So here we have 4 levels: September 1, October 2, November 3, and December 4. And that is basically it for this part. Other things that we want to do here is typically we want to click on options, and we will want estimates of fx size, notably. Right, so let's click on estimates of fx size. Let's click on continue. Also, in the plots, I may want to plot my outcome as a function of the month. So the only thing I need to do for that is select month right here and put it in the horizontal axis, and I'm just going to add a plot. It's basically going to plot the means at the 4 different levels. That's a good way to sort of see what's going on descriptively. Right, so clicking on continue. Then the next step, we may want to know which of these differences, right, are significant, right? Because it will tell us if there's a significant, an overall significant mean difference between all of these groups. So once again, we don't know where they are. So let's click on post arc here. I'm sorry, we cannot select them from there. We need to select them from options, and we need to select month and put it here on the right box, and click on compare main effects and select LSD. Let's click on continue, and let's click on OK. Right, so let us scroll down. First thing we have here is a check of the assumption of sphericity. Right, so it tests a null hypothesis that the error covariance matrix of the auto-normalized transform dependent variable is proportional to an identity matrix. Basically what it does is it checks that you have similar covariances between different levels here of the outcome. So in other terms, the relations between September, the levels in September and October should be overall the same as between October and November and as between November and December. So it's basically what it checks here in the assumption of sphericity, which is here using Moschli's test not significantly violated. So here we will be safe choosing this first line of assumed sphericity. And so we find here in this test of within subject effects, which is what we want to know about, that the month has a significant effect on the level in statistics. We didn't doubt that. Partial eta squared tells us here that it's a strong effect. So here we can quantify the effect using, once again, partial eta squared. Okay, so if we scroll down, we will also have pairwise here comparisons using LSD, least significant difference, because we called for that. And here what we see is that basically there are mean differences nearly everywhere, because there are significant mean differences between month 1 and month 2, month 1 and month 3, month 1 and 4, 2 and 1, 2 and 3, 2 and 4, 3 and 1, 2, 3 and 2, but the only non-significant mean difference is between month 3 and month 4. And actually if we see here the data, so it's basically we have mean differences between all of them except between these two, which is consistent with what we see here in the means plot. Alright, so thank you for watching this short video on how to perform a repeated measures ANOVA.